Hello, this is Daniel, and today I am going to show you how to configure and program your ECC-1 evaporative cooling control. Before I dive into that, let's do a quick overview of the backboard. Taking a look at the inside of the control here, we can see we've got our power terminals where we will put our incoming power. Then we've got a temperature terminal where we would connect our first temperature probe. If we are going to use a second temperature probe, that's going to be in this terminal here to the right of it. The next terminal is for a sensor, and that is for the RHS relative humidity sensor. And that is an optional sensor that you can use. And then finally, we have our alarm relay terminal here. If you are connecting up an alarm system, that is where you would wire it in. And then of course, we've got relay 1, 2, 3, 4, 5, 6, our 6 different relays that are available for you to use. I will now show you how to configure some of the basic settings on the ECC-1. We will go into the main menu and go into maintenance. In here, we can set the clock, we can set the date, and can adjust it. Adjust the day, adjust the year, and then as well we can adjust the time. Next, we can adjust what temperature units we are using. So we have the option for either Fahrenheit or Celsius. We can adjust the frequency. Our power here is 60 Hertz, but if you want to change it to 50 Hertz, then you can do so here. We also have the display options here. So in here, we have 4 different basic display options, as well as some alternate pieces of information that you can have displayed. So display option, your main display, you've got 1, 2, 3, and 4. And display option number 1, it will on your main screen when you're, just first looking at your control, what you will see is the control name ECC-1 in the top left, the time in the top right, and then your temperature probe 1 in the bottom left, that reading. If you go with option 2, you will have ECC-1 in the top left. Then you'll have your temperature probe number 1 on the top right. The bottom left will be the time, and then the bottom right will be your temperature probe number 2. Option number 3 has ECC-1 in the top left, time in the top right, and then temperature 1 in the bottom left, and relative humidity in the bottom right. And then finally, if you want to see all of your different probes, you can have ECC-1 in the top left, temperature in the top right, temperature 2 in the bottom left, and relative humidity in the bottom right. And that is mode number 4. Additionally, you can have secondary pages. If I scroll down here, you can see relay states. Right now that is turned off. Probe temperatures, that is turned off. Daily temps, run durations, And also here we can adjust how frequently it will update. So I will just go through those different options here. So relay states, that will display the state, whether each relay is on or off. So that can be a secondary page on your main screen. It'll scroll through between the main page showing you your information, one of the 4 options, and any of these additional pages that you activate. So we can have a relay page or a relay state page. We can have probe temperatures. So that is going to display the current temperature for each probe. So probe 1 and probe 2. We have daily temperatures. So this displays the high and the low temperatures for each probe for the current day and the previous day. So probe number 1, high and low for today, high and low for yesterday. And then probe number 2, high and low for today, high and low for yesterday. And then the final option for bonus extra information pages is the run durations. And this displays the total run or on time duration of all your sprinkler relays for the current and previous day. So it'll give you a current day run duration and a previous day run duration. So those are your options for your main display information that you can have very quickly and readily available. Finally, in this maintenance menu, you can do a cycle reset. And what this will do is if you are currently in the midst of a cooling cycle where your sprinklers are turning on and cycling through them, if you want to reset your cycle, maybe all your sprinklers have cycled on, they've cycled off, and now you're just in the downtime where your fans are running. If you want to reset and start a new cycle again, you can here hit the cycle reset and it will restart your current cycle. And that's something, you just hit it, and you could see if you go back and look in the video, sprinkler number 2 was on. I reset the cycle, and so now it went back to the start. So now sprinkler 1 is back to being on. Let's move on to the configuration menu. And I will show you how to configure your relays. So of course, we have 6 different relays, and they can be configured in a few different ways. So first off, you can configure them as being unused, which is this none. You can also have an independent fan going off of probe number 2. So you can have this relay running just a fan that will have its own unique set point based on the temperature reading of probe number 2. You can have an independent fan running off of probe number 1. Same sort of idea, just off of the other temperature probe. You can have a dependent fan. So that means it is going to be running with your misting and fogging cycle. It'll be dependent. You can have a pump, which if your system needs to be pressurized before you turn on your misters or foggers, then you will need to set up a relay as a pump to pressurize your system. And of course, we've got the sprinkler or mister fogger, any sort of water output. That's what you are going to configure your relay as. So let's go ahead. I am going to configure relay 1 for a pump. Oops, back. Relay 2 is a sprinkler, great. Relay 3 is a sprinkler, great. Relay 4 is a sprinkler, great. Let's do relay 5 as a dependent fan. And then relay 6 we will do as an independent fan running off of probe number 2. And then down at the very bottom, we do have the control mode setting. So in here, you will select whether you are in soaking mode or in misting and fogging mode. Let me explain how this mode works. So in misting and fogging mode, you will have a set amount of time that is your cycle time. And then you are going to have a variable amount of time that your misting will be on for. So as your temperature increases, your misters are going to stay on for longer periods of time. So you get more water from each of your misters as the temperature increases, but your overall cycle time stays the same. If we're in soaker mode, we're going to have a set time that our soakers are going to be on. So our water will be consistent. It's always going to be on for the same amount of time. But our cycle time, that is going to reduce as the temperature rises. So again, as the temperature rises, our watering will be for the same amount of time, but our overall cycle will reduce, which means that we will be watering more frequently. So you get more water more frequently when the temperature rises in both soaking and misting and fogging modes. Just the way that we do it is slightly different. For now, I am going to leave it in soaking mode. Let's go ahead and take a look at the settings for soaking mode. So in here, we can set up our sprinkler control. Now remember, in soaking mode, our soak duration is going to stay the same. And for this example, I've got 3 different soakers because I've got a pump and then 3 soakers and then an independent and dependent fan. That's my 6 relays. So we can leave our soak duration at 3 minutes, sure. And then our minimum cycle, this is in hours and minutes. So our minimum cycle is going to need to be at least 9 minutes because we've got three soakers that each run for 3 minutes, one after the other. And so that is a total of 9 minutes. Plus, we have relay 1 set up as a pump. And a little bit later on, the next setting we're going to set up is going to be how long we're going to delay at the start of a cycle to allow the pump to pressurize our system. So that's going to be, say, 10 seconds to give that pump time to pressurize the system. So that means actually our minimum cycle needs to be the 9 minutes plus the 10 seconds for our pump. So of course our cycle duration is in hours and minutes. And so we would need to round that up and actually say 10 minutes is going to be the lowest cycle that will work. However, if our temperature is really hot, we don't want us to be, soaking just constantly. like a 10-minute cycle would have. We do still want to give an opportunity for the water to evaporate and actually pull some of that heat from our animals, from where we're soaking. And so we do want to leave some time for that evaporation to occur before we run another soaking cycle. So all of these numbers that I'm putting in are just example numbers. Obviously, you will have to figure out what makes sense for you, for your system, for your animals, what is going to give them the healthiest environment. But for my example here, I will do a minimum cycle of 15 minutes. And then maximum cycle. This, obviously, we're going to do greater than our minimum cycle. And I'm going to do that at 30 minutes. So when the temperature is cooler, we're going to have 9 minutes of soaking with the 10 seconds of pump delay, and then 20 minutes for evaporation. And then as the temperature increases, we're going to go all the way up to that 9 minutes of soaking and then 6 minutes of evaporation time before we trigger another cycle. We can now set the temperature range over which our soakers will be activating. So the low temp, this is the temperature at which, or I should say the temperature below which, we're not going to be doing any soaking. So below 70 degrees, no water, no soaking. Once we pass 70 degrees, then we are going to do that maximum cycle. So we're going to run all of our soakers and then wait for the 30 minutes to be completed. And then we're going to read the temperature again. If we're above 70 still, then we're going to run another cycle. The high temperature is the temperature at which we're going to start reducing that cycle time. So here at 80 degrees, once we hit 80 degrees, then we're going to start reducing that cycle time from 30 minutes down to the 15. And our max temperature of 90 degrees, that is the temperature at which we are going to achieve that 15-minute cycle time. So if our temperature is 85 degrees, halfway in between, then we are going to be halfway in between our max and min cycle. So max cycle is 30, minimum cycle is 15. So that's going to be about 7.5 minutes. So at 85 degrees, we'd be looking at about a 22.5 minute cycle. So as the temperature rises, our cycle time reduces. So that is the basic settings for our soaking. We have our pump control setting. In here, you can see we've got our delay set to 10 seconds, and that's exactly what I was talking about before, where we will give 10 seconds right at the start of the cycle for where our pump relay will turn on, and we'll wait those 10 seconds before we turn on our first soaker relay, just so that our system is pressurized. We have our fan control. So in here, this is where we set our independent fans. So our dependent fans, those are going to turn on and are going to run whenever our cycle is active. So when we had 70 degrees was our low temperature set point, anytime that we are above 70 degrees, it doesn't matter if we're at 70, if we're at the 80, if we're at the 90, it doesn't matter how long that cycle is. If the cycle is active, then that dependent fan is going to be running. Our independent fans, however, remember we had one that we had set up for, I believe it was probe number 1. So here we can set up an independent fan that isn't running when the cycle is active. it is solely running when our probe is at a certain temperature. So we could set this one, and we could set it, let's say, at 80 degrees. So when that temperature starts rising, when it's getting up there, then we're going to kick on a second fan. It's not going to run based on the cycle of soakers. It's going to run based off of this temperature set point. And we do have probe number 2 set point for independent fans. If we had one that we had configured that way, then we could set that up as well. And then as well, we have our hysteresis, which is basically the amount of overshoot that we have. So what I mean by that is with our set point of 80 degrees, when we go above 80 degrees, that fan is going to turn on. With the hysteresis set to 3 degrees, that fan is going to stay on until we have cooled down to 77 degrees. Once it gets below 77, the fan turns off, and then it doesn't turn on until we hit that 80 degree set point again. Our fourth option in our settings is for humidity. So in here, by default, our humidity sensor is disabled, but we can enable that if we have one connected. And then we have a set point here. And this is basically a high humidity cutoff set point. So with this, we are saying if our humidity reading is 85% or greater, then if the temperature is hot enough that it is triggering a cycle, instead of actually triggering our pump and triggering our soakers and adding more water to an environment that is already quite humid, instead, we will just trigger the cycle and we'll only run the fans. We won't run the soakers. And so this allows you to not add extra humidity, extra water to an environment where it's already very humid and you just need those fans running to hopefully try and evaporate and cool things down. And obviously you can adjust that set point to a setting that works well for you. And again, hysteresis, you can set that to what you want it to be. And this one, because we're working in percentages, is a percentage. We have an alarm setting as well. So in here, we have our probe 1 alarm, and that is enabled. That is if it detects that the probe is damaged. Probe 2 is disabled because by default, we're thinking you're only using the one temperature probe. If you do have a second temperature probe connected, then you can enable that. We've got a high temperature alarm. So you can adjust this if you want it to alarm when the temperature gets too hot. As well, a low temperature alarm. So this control does not control heaters or anything like that, but you can have it alarm if the temperature that it is measuring does go too low. Maybe your control that is controlling your heaters doesn't have an alarm. Either way, you can do it off of this control just so you have that completeness of both high and low temperature alarms. The sensor alarm, that is going to be for your humidity sensor. So if we have a humidity sensor connected, then we can enable that to tell us if our humidity sensor becomes damaged. And then we can select what level we want our high humidity alarm to alarm at. And then of course we've got duration for our alarms. And I will just insert in here a little extra information. The duration setting for alarms is the amount of time in minutes and seconds that an alarm condition needs to be present for the alarm to actually activate. So here we've got a 1 minute duration, which means that, for example, if it's a high temperature alarm, your temperature needs to be above your high temperature alarm point for a continuous minute for that alarm to trigger. So this allows you to adjust how quickly you will have your alarms going off, so that if you just pop over your high temperature alarm for 5 seconds, your alarm's not going off right away, but it needs to be an actual continuous for a whole minute that you are above that alarm setting. And so you can adjust that. Like I say, it's in minutes and seconds, so up to 59 minutes and 59 seconds, or as low as 0 minutes and 0 seconds if you want an immediate alarm. Let's get back to the video. And silencing, how many minutes it will silence it for, so that we can go and actually fix what is wrong. Active time. So this one is quite important. If we go in here, we can give it a start time and a stop time. And so maybe you don't want your soakers to be running 24/7. Maybe you only want them to be active during our daylight hours when it's actually going to be hotter. And so here you can select your start and your stop time, during which the control will actually be active and actually be starting cycles if it is reading a high enough temperature to do so. Of course, if you want 24/7 operation, you can set up your start and stop to have it be active 24/7 if that's the way you want to run it. And finally, at the very bottom, we do have defaults. So if you want to erase everything and load your defaults, you can do that as well. I will now go into the configuration. I will configure it for misting and fogging, and then show you what the sprinkler settings look like for that. All the other settings are going to look the same. So we change our control mode to misting and fogging. And then when we go into settings, everything's going to be the same except for in here, our mister control. We are going to have our cycle duration. And again, remember, the cycle, now that we're in misting and fogging, the cycle is going to stay static. So right now, let's do maybe a 15-minute cycle time. Then our misting duration, that is what is going to vary. So our minimum misting is 1 minute. That works okay. Maximum misting of 2 minutes. That also works okay with what we've got. So low temperature 70, high temperature 80, max temperature 90, that looks all good. Cycle duration, 15 minutes. Perfect. So, just to talk through how this works, at 70 degrees, we're going to start with basically our minimum amount of misting, which means we've got a 15-minute cycle with a 1 minute mist duration. So 1 minute, 1 minute, 1 minute for each of our 3 misters. So we'll have 3 minutes of misting and then 12 minutes of just the fans. And then as the temperature rises, once we get to 80, it's going to start ramping up our mist duration. And so let's say, again, once we reach 90, we're going to be at our maximum misting. So 6 total minutes of misting and then 9 minutes of just the fans to complete that 15-minute cycle. And then using the same example, if we're at 85 degrees, halfway in between, we are going to be halfway in between for our misting duration. So that's going to be 1.5 minutes. So we're going to have 4.5 minutes of misters and then 11.5 minutes of just the fans to finish off that cycle. And then again, checking the time, looking to see what it should do. And then again, checking the temperature and seeing what it should do. And if you ever get an alarm, you can see there, just hit the check mark to acknowledge that alarm and it will clear it. Again, I believe I had the alarm clear setting for 5 minutes, so it'll clear it for that 5 minutes. I have one final piece here to show you guys. I realize I never showed you the manual override in the maintenance menu. So we're going to hop back there and I'll walk you through that. So we go down to the maintenance menu and then go to our option number 1, manual control. In here, we can manually control all of our 6 different relays. When we enter into manual control, it will keep whatever relays we're already on will stay on. Whatever relays were off will stay off. So if we're in the middle of a cycle and we've got some sprinklers or pumps or fans running, they will stay on. But once we're in the manual control, then we can select, let's say relay 1 here, and we can turn it on instead. We can turn relay 2 on. If we want to turn relay 5 off, we can do that. And so this is helpful for troubleshooting and just verifying that your equipment is connected properly and working as you expect it. When you exit the manual control mode, it is going to reset your cycle. So it'll do the exact same thing as that reset cycle option, where it will go back to the start, read the temperature, and decide if it should start a cooling cycle. So that is the manual control option in the maintenance menu. So that is how you configure and program the ECC-1. I hope that this video was helpful, and if you have any questions or comments, then feel free to put them down in the comment section down below. Having said that, that's going to do it for this video, and I hope to see you guys in the next one.